Level 0. Most people assume a volcano means run. That instinct is wrong more often than you'd think. A Hawaiian eruption is the one style where crowds gather instead of scatter. Thin, fluid lava lets gas escape easily instead of trapping itself underground. So, instead of an explosion, you get fire fountaining, glowing jets of molten rock bursting from a crack in the earth, sometimes lasting for hours, sometimes for days. In 1959, the Kilauea Iki eruption on Hawaii's Big Island sent a fountain 580 meters into the sky, taller than the Empire State Building. The crowd never left. The lava it produces can crawl for miles without stopping, patient and unhurried, swallowing roads and houses at walking pace. People rarely lose their homes because they couldn't outrun it. They lose them because they waited to see how far it would go. Calm doesn't mean safe, it just means slow enough to fool you. And the moment that same magma stops flowing freely, this entire pattern collapses. Level 1. 2,000 years. That's roughly how long a single volcano has been erupting on and off, reliably enough that sailors once navigated by its glow. The volcano is Stromboli, on a small island off the coast of Italy, nicknamed the Lighthouse of the Mediterranean. Unlike the continuous fountains of a Hawaiian eruption, a Strombolian eruption works in bursts. A large gas bubble rises through thick magma, gets trapped, builds pressure, and finally pops at the surface, launching glowing bombs of molten rock hundreds of meters into the air. Then it goes quiet. Then it happens again. Sometimes minutes later, sometimes seconds. That rhythm is so reliable that tour companies built entire businesses around it. Guided night hikes timed to the glow, which made what happened in July 2019 so alarming. Stromboli produced a sudden explosion far larger than its usual pattern, without warning, killing a hiker who had followed every rule the volcano had ever taught anyone. The exact sequence behind that jump is still being studied. Keep it in your back pocket because the next level explains exactly what happens when a volcano stops releasing pressure gradually, one bubble at a time, and starts building it up instead. Level 2. Picture a kettle left on the stove long after its spout fused shut. The steam doesn't stop building just because the exit is gone. That's roughly what happens beneath a Vulcanian eruption. Thick, sticky magma cools near the surface and hardens into a plug, sealing the vent shut. Gas keeps building underneath with nowhere to go, and pressure climbs until the plug simply cannot hold. When it finally gives way, it doesn't ease out. Debris launches at speeds exceeding 350 meters per second, faster than a commercial jet at cruising altitude, rising kilometers into the sky within seconds. The eruption itself might last minutes. The ash cloud it leaves behind can drift for hundreds of kilometers, grounding flights on the other side of a continent. The name comes from Vulcano, an island the Romans believe sat above the forge of their smith god. Guatemala's Santiaguito has been repeating this exact style since 1922, one explosion after another, a volcano that never quite finishes clearing its throat. Some volcanologists suspect that unpredictable jump in Stromboli's rhythm wasn't a rhythm break at all. It may have been a small Vulcanian-style plug forming and failing inside a system built for something gentler. The rules aren't as separate as they look. A plug of solid rock is still something you can picture, though. A blockage that isn't rock at all works very differently. Level 3. Off the south coast of Iceland, fishermen once watched the sea itself catch fire. That was November 1963. Magma meeting seawater doesn't cause gentle chemistry, it causes an explosion, because water expanding into steam increases in volume by roughly 1,700 times, almost instantly. Within days, a column of ash and scoria had piled high enough to break the surface, and a brand new island stood where open ocean had been the week before. They named it Surtseyan. That's the strange power of a Surtseyan eruption. It doesn't just destroy land, it manufactures it. One violent pulse at a time, dark cauliflower-shaped clouds of ash and steam rising every time fresh lava touches water. That same interaction turned catastrophic again in January 2022, when an undersea eruption at Hunga Tonga in the South Pacific sent a plume over 20 kilometers into the sky and triggered a tsunami that crossed the entire Pacific Ocean, one of the most powerful eruptions instruments have ever recorded. Water couldn't stop the magma. Thick rock proves to be a very different challenge. Level 4. Some volcanoes look finished. That's usually a lie. A lava dome forms when magma is so thick it barely moves, piling up directly over the vent instead of flowing downhill, closer to toothpaste being squeezed out in slow motion than anything resembling a river of fire. It can sit there quietly for months, occasionally puffing steam, looking to almost anyone watching like a story that's already over. It isn't over. Pressure keeps building beneath that solid crust, and domes have a habit of collapsing with almost no warning, sending scalding avalanches of gas, ash, and rock racing down slope at speeds that can exceed 100 kilometers per hour. These are called pyroclastic density currents, and they move faster than most people can process what they're looking at. Mount St. Helens spent years rebuilding domes after its catastrophic 1980 eruption. Each one eventually collapsed. Each collapse was a smaller rehearsal of the disaster that came before it. Chile's Chitin and Alaska's Redoubt have shown the identical pattern. Quiet accumulation, sudden failure, repeat. Even without fresh magma, gravity alone can bring a dome down. No new eruption required. A volcano can look completely dormant and still be capable of killing everyone downhill without a single new drop of lava ever reaching daylight. Gravity never stops working, even after the volcano appears to have fallen silent. There's a colder version of this same pressure problem, though, one that isn't sealed inside a dome at all. Level 5. Most people picture an eruption spilling downhill. The most violent style on this list doesn't behave that way. It goes up. A Roman writer named Pliny the Younger watched it happen in AD 79, describing a column of ash so tall it looked like an umbrella pine tree stretching into the heavens. He had no volcanology to explain what he was seeing, only the honest account of someone watching Vesuvius erupt from across the bay. Scientists later named the category after him. A Plinian eruption happens when gas-saturated magma fragments almost instantly as it rises, blasting a column of ash and superheated gas up to 50 kilometers high, at speeds measured in hundreds of meters per second, faster than a fighter jet moving straight up. That column does not stay put. It can drift for thousands of kilometers and blacken skies on the far side of a continent. When it finally collapses under its own weight instead of drifting away, it doesn't fall as harmless ash. It falls as a pyroclastic flow, fast enough to outrun a car, hot enough to kill within moments, burying entire communities beneath layers of ash and preserving Pompeii as one of history's most haunting archaeological sites. Mount St. Helens used this same mechanism in 1980, stripping an entire mountainside bare within minutes. A Plinian eruption is frequently the climax of a volcano's whole cycle, violent enough to empty a magma chamber so completely the mountain can fall silent for centuries afterward. Emptying a chamber and destroying one aren't the same thing, though. Past this level sits a threshold researchers discuss carefully, almost reluctantly, because crossing it stops being about one mountain and starts being about the whole planet's climate. Level 6. No footage exists of this level. Nobody alive has ever filmed it. Push a Plinian eruption past its usual ceiling, and you reach Ultra-Plinian territory. Ash volumes measured not in millions, but in hundreds of cubic kilometers. In 1815, Mount Tambora in Indonesia produced an eruption this size, dropping global temperatures enough to cause what became known as the Year Without a Summer in 1816. Crop failures were reported as far away as New England and China, all from a single mountain most people today have never heard of. Beyond Tambora sits something researchers discuss even more carefully. A supervolcano, a caldera forming eruption on the scale of Yellowstone's prehistoric events, capable of ejecting over 1,000 cubic kilometers of material in one episode. It has never happened within recorded human history. It has happened in geological history more than once, and the evidence is written into ash layers scattered across entire continents, still being studied, still being argued over. Every mystery the script left dangling, Stromboli's broken rhythm, the dome that doesn't need new magma, the ocean that couldn't stop the fire, all of it circles back to the same unanswered question. No one knows exactly when the next eruption of that scale will happen. The planet has never allowed anyone to witness one in recorded history. only to study the evidence it left behind.